My name is Karen Howe, and this is our module on the past, present, and future of AI. So in this module, we'll cover the definition of AI, we'll go through a brief history of AI development, and then we'll talk about the modern day AI development paradigm. And I want you to keep this in mind. The story of AI has always been about ideology, money, and power. These are the three lenses through which to understand how AI became what it is today, and to understand how it continues to impact people and communities around the world. Let's start with a definition. What actually is artificial intelligence? Well, there's a common misconception today that AI is one thing. The world was introduced to AI as ChatGPT, so people believe AI is ChatGPT or ChatGPT is all of AI. And in fact, AI is actually many different technologies that are all loosely tied together with one commonality. That is that they're designed to mimic human capabilities. I would go one step further and say that AI is a name for many different technologies. And I'll explain what I mean in a moment, but making this distinction is a key step to disentangling the reality and the hype of what AI is today. So what do I mean that AI is a name? Well, the term artificial intelligence was literally coined as a name for a new field in 1956 at a Dartmouth University summer gathering in the US. And it was introduced by this guy, John McCarthy. McCarthy was an assistant professor at Dartmouth University, and he was working on research to build so-called logic machines. If you have ever seen The Imitation Game that documents the work that Alan Turing was doing during World War II to crack the Enigma code, that hulking machine behind him is effectively also a logic machine. And so McCarthy was building similar types of machines for the explicit purpose of doing things like solving complex math problems. And at first, McCarthy called his work automata studies, but that didn't catch on. And in looking for a better term to appeal to funders, to scientists, and to the public, he ended up coming up with a more evocative name, artificial intelligence. And so the name artificial intelligence was actually a marketing trick, and it worked really well. And it also became a new framing for what McCarthy and other scientists were trying to do. They weren't just building machines to do math, they were trying to recreate human intelligence with computers. And that becomes a guiding ideology for the field all the way up until present day, continuing to affect different companies like OpenAI and DeepMind in their pursuit of what they're doing. But the thing is, AI has always been a rather ill-defined term. And Marvin Minsky, another founding father of AI in this photo, he used to call AI a suitcase word. You shove whatever meaning you want into the suitcase and suddenly AI becomes that. And that's because many different scientists over the years have had radically different opinions about how to recreate intelligence. There have been heavy disagreements about what AI should look like, what technologies we should use to achieve it, and what purpose it should serve. So over the decades, what we have called AI has actually changed a lot. And the technologies considered AI today work completely differently from what was considered AI in the past. That said, there is a central vision that comes to dominate during each era of AI development for what AI should look like and how it should work. And that is ultimately based on who has the money and the power to push their vision. So in the early days, what is the dominant vision of AI? Well, one example is the system from 1964 called Eliza, and it was devised by an MIT professor named Joseph Weizenbaum. And on its surface, it actually looked kind of a lot like ChatGPT. It was a chatbot that you could chat with, and it was designed, one instantiation of it, was designed to be kind of like a psychotherapist. Under the hood, it worked completely differently from ChatGPT and other chatbots today. It was actually a system that simply followed a set of hard-coded rules. So you would say something like, "Hi, Eliza, I'm feeling down today." And it would just reflect back, based on a method of psychotherapy, the key words of what you said. Why are you feeling down today? My friend said something mean to me. Do you think that it's normal that your friend said something mean to you? Obviously, this is a very simple system, and you can sort of see already how exactly it works. But people found this simple system incredibly impressive. This rule-based system became the dominant vision for AI development. And anyone that was working on AI development basically started trying to build these rule-based systems, believing that if you could encode more and more complex rules into a single AI system, that would recreate artificial intelligence. That's nothing like how ChatGPT works today. There are no hard-coded rules dictating what ChatGPT says back to the user. Instead, it's a statistical engine. It's trained on vast swaths of internet data to learn patterns of language, and it uses those patterns to construct new sentences that effectively continue to reflect back to the user something related to what the user said. And people now find ChatGPT incredibly impressive. So this statistical engine type methodology for developing AI has become the new dominant vision for AI. And what's more, there's now a new term on the block, artificial general intelligence, which OpenAI popularized when it was founded in 2015. And that is supposedly the new name to refer to human-level intelligence in computers. Again, it's a marketing trick that's really working. AI used to mean the same exact thing, and then the term started cheapening over time as more and more people used it to refer to not human-level intelligence. So now artificial general intelligence is being used to evoke the same original goal. And just as the term AI became associated with Eliza, the most impressive demonstration of AI technology back in the day, now AGI is being linked with ChatGPT, the most impressive demonstration of AI today. And we're supposed to believe that these statistical chatbot tools will somehow lead to the creation of a fundamentally new form of intelligence. So the dominant vision has shifted from rule-based systems to increasingly big data, big compute systems. And data here refers to mass scrapes of the internet, whereas compute is this kind of industry term that refers to raw computational resources. How big, how fast, and how powerful is your computer for developing AI? And how long are you running it for? This is now the formula that drives modern day AI development. If you put more data, more compute into a single AI system, supposedly you will get more and more advanced AI capabilities until you one day reach AGI. And why has this vision shifted? It really comes down to who is developing and who is funding AI in each era. So in the early days, it was academics that were leading the charge on AI development, and it was governments and foundations that were giving the academics the money to fund their work. In modern day, it's big tech companies who are leading the charge on development and have their own funding. And the thing is, companies have massive troves of data, and they have a lot of cash lying around to buy really big computers. And ultimately, they're motivated by developing AI with some kind of commercial viability. And so you can see how those elements begin to shape what ultimately emerged as generative AI today. So this new dominant vision has really propelled a rapid escalation in the amount of data and compute that is being used to build AI models. This is a chart of the amount of data that's being used to train a single AI system over the decades. And you can see that in more recent years, the amount of data used in systems today completely dwarfs the systems of the past. And this chart is already outdated. It ends in 2020. But we know anecdotally that in the last 5 years, that has continued to go up and up and up and up. The same story goes for compute. We can see that just from the trajectory of OpenAI's technologies. So here on this slide, parameters of an AI model, that refers to a proxy for the amount of data and compute that is being used to train a single model. So in 2019, GPT-2 had 1.5 billion parameters, And that was actually already the largest AI model at the time. But fast forward 4 years, in 2023, GPT-4 reportedly had 1.8 trillion parameters. So compute increased roughly 3 orders of magnitude in 4 short years. And what that means in practice, where AI models could once be trained on, let's say, a powerful laptop, or maybe a few dozen computer chips, the generative AI models that are being built today by companies like OpenAI require supercomputers with tens of thousands of computer chips, and they need to be trained nonstop on the order of months. Those computer chips are calculating around the clock, they're consuming extraordinary amounts of energy, they're creating heat, noise pollution, and that is happening for months. OpenAI isn't stopping there. Earlier this year, you may have seen that President Trump announced a new joint venture between OpenAI, SoftBank, and Oracle that will supposedly pump $500 billion of private sector investment over 4 years into building more and bigger data centers or more compute, which OpenAI says will be for itself. To put that into context, the Apollo program that sent the first man to the moon cost around $300 billion over 13 years when you adjust to $2025. So this is an extraordinary amount of capital that is being funneled into the production and creation of generative AI development. And most of the companies, not just OpenAI, are now pursuing generative AI along this trajectory. And they're trying to pour ever more data, ever more compute into these systems. And this is where that vision is leading us. Generative AI is now so resource intensive that it's running out of things to consume in the world. It's running out of text on the internet. It's running out of computer chips in the world. It's running out of energy on the grid. And the funny thing is, something happened recently that started to really call into question whether or not this paradigm is actually the most effective. Deepseek. So Deepseek, a Chinese startup, developed a generative AI model with what they said were significantly lower resources, where firms like OpenAI had been reportedly spending hundreds of millions or billions of dollars to train its AI models. Deepseek reported that it spent less than $6 million. So we really have to critically examine whether the dominant paradigm for generative AI development and all of the costs associated with it, environmental, energy, other costs, are actually really necessary. It bears reminding that this is very much a path being driven by some of the wealthiest companies in the world. Of course, they have this vision. They are the only actors in the world that get to participate in it. So it is the perfect competitive advantage for them. No one else has the kinds of resources at their disposal to compete. And I used to have Chinese companies on this slide, but increasingly, the US government has placed restrictive export controls on the ability for Chinese companies to get access to the most cutting-edge AI chips, which means they no longer have the kinds of resources at their disposal that American companies do. And that is part of the reason, the part of the environmental factors that led to Deepseek doing what it did. This is a really critical dimension for thinking about how AI impacts your country. Many of you are going to be watching this video from countries or contexts that do not have the same resources as these companies. So the generative AI technologies you interface with will most likely be exports from the US and maybe sometimes from Europe or China. And within them, there will be embedded very specific ideologies and assumptions from those contexts. And you should examine, do those assumptions serve your community? Where do they fall apart? Who benefits and makes money in the process? And who gets harmed along the way? So here are some common mistakes in AI reporting. The first is accepting AI as what it is without questioning the premise of why it is that way. And an example of this might be if you were covering the $500 billion Stargate project And you stated as a fact that future AI systems could need this level of compute investment. A much more accurate statement would be that OpenAI's vision of AI development demands this amount of compute. And that then begins to prompt the important question of whether we want this vision and whether OpenAI should have the power to determine that. The second mistake is referring to AI as one technology. An example of this kind of story is one that I see a lot. AI has risks and opportunities. AI could help save us from climate change, or it could help accelerate climate change. The problem with these kinds of stories, especially the climate change one, is that the two mentions of AI in the headline actually refers to different sets of technologies within the broader AI umbrella. So there are some AI technologies that can help tackle key issues when it comes to climate change, and the models themselves have actually very little environmental impact. For other AI technologies, the reverse is true. So covering those details with nuance can help make visible which AI technologies generally the public would want to keep and which ones we would want to cut out. And then it can also help figure out, ultimately, how do we want to develop new AI technologies that are maximally beneficial and minimally harmful? The third mistake is quoting AI business leaders or others with financial ties to the AI industry as experts without actually acknowledging those ties. Increasingly, we're seeing that a lot of AI experts now work for the companies that profit off of selling a particular vision of AI development. And so it's become harder and harder for journalists to find independent experts to speak to. And so instead of necessarily restricting yourself to just independent experts, just make sure that when you are quoting these types of individuals, to highlight what kinds of financial conflicts of interest they might have. The fourth one is anthropomorphizing AI as human-like intelligence. We've already mentioned AI is a marketing term. Let's not feed into that hype. It doesn't really help the reader understand what is exactly happening under the hood. And it also doesn't help them discern what AI can and can't do. And lastly, the final mistake is forgetting that this is a story about people. It's people who develop this technology, and it's people who are impacted by the technology. And this is one of the best ways to make AI what would seem kind of invisible or difficult to understand much more concrete and relatable.